This lesson is about independent and dependent events, two more types of probabilities that we can come across. Independent events is when event A occurring does not affect the probability of event B. They're independent of each other. They don't involve each other. The formula for that, we use the word and. So A and B are happening. They're both happening just separately. They don't need each other. So remember, and is that word intersection, represents intersection. And we're going to multiply these probabilities together. So a coin is tossed and a six-sided die is rolled. Find the probability of landing on head and rolling a 3. So thinking of a coin, hopefully we know that a coin only has two sides. And I always pick a marker that's dead. A coin has two sides, so if we want the head side, we have one option out of 2. Okay. Then when we think about a six-sided die and rolling a 3, well, if I have numbers 1 through 6 on this die, then rolling a 3, there's a 1 out of 6 opportunity. So we get to multiply these because we saw the word and that's equal to 1 over 12. And that's our final answer. That's simplified. Remember, when we multiply fractions, we multiply across the numerator and we multiply across the denominator. And then we can divide to simplify later. Alright, so a card is chosen at random from a deck of 52. It is then replaced and the second card is chosen. What is the probability of choosing a jack and an 8? So what if we wrote this using our equation? Just so you're familiar on what it's going to look like. Okay, we have this first event of choosing a random card. And we want it to be a jack. So I would say the probability of choosing a jack, then I see this word and now tells me to use multiplication. And then it says we're still in a deck of 52 cards, okay, and we're still choosing in 8. So I would say the probability of 8, okay, and then I can write that out, right? So that's going to equal. So the probability of a jack, if I think of a jack out of 52 cards, remember there's one jack in each suit and there's 4 suits. So this is going to be 4 out of 52. Then we have that word and. The probability of 8. So again, there's one number 8 in each suit, but there's 4 suits. And then we'll multiply across the top, multiply across the bottom, and we always look to simplify. And that equals 1 over 69. 169, excuse me. Remember, probabilities are fractions. Unless I ask you specifically for a decimal, probabilities will always be fractions. Now let's talk about one more key word here in this word problem for finding an independent event. I know that this is independent just by reading it because of this vocabulary replaced. I had a deck of cards, I picked one out, I looked at it and I put it back. When it's replaced, that's the key word for independent. That's the key word for independent. So let's look at another example. A jar contains 3 red, 5 green, 2 blue, and 6 yellow marbles. So how many marbles are in that jar? So 3 plus 5 is 8, 2 plus 6 is 8, 8 plus 8 is 16. So we have 16 total marbles. We need that for our denominator. All right, a marble is chosen at random from the jar after replacing it. So again, that's an independent event. After replacing it, a second marble is chosen. What is the probability of choosing a green and a yellow marble? So choosing a green comes first. There are 5 green out of 16. And we'll multiply because we see this word and. Then we see choosing a yellow marble. So I picked one of those 5, looked at it, put it back. And so I have 6 out of 16 marbles. So that equals 30 out of 256, I do believe. 16 times 16. Yep. So we'll look to simplify that fraction. Is 15 over 128. So again, let's break this down some more. We know now that replacing means that we have an independent event, but let's talk a little bit more about why. So if I stick my hand in a jar, I have 5 opportunities out of 16 to pick a green. So when I pick that green, I now have, and that green is sitting in my hand, I have 15 marbles in my jar. But when I put that marble back, I put my total back up to 16, making them independent. Okay. All right, a school survey found that 9 out of 10 students like pizza. If 3 students are chosen at random with replacement, what is the probability that all 3 students like pizza? So they found that 9 out of 10 students like pizza. 3 of them are chosen at random without replacement. So I choose you, I put you back, I choose you, I put you back. What is the probability of 3 students, of those all 3 liking pizza? So our probability is going to be, sorry, I'm looking for my answer key because I always hated the wording of this problem and I don't want to tell you the wrong answer in all of my life. Yeah. Alright, so think of it this way. You're looking at your class and the first time you go to pick, you have a 9 out of 10 chance of choosing somebody who likes pizza. However many you pick out of those 9, there's still 9 left when you have that student sit down. So the next time you pick, you still have 9 out of 10 students who like pizza. Then you have them sit down, and you pick a 3rd student, and there's still 9 out of 10 students who like pizza. So again, we see that word replacement, so we know it's independent. So 9 times 9 times 9. 10 times 10 times 10. 729 out of 1,000. And that can't be simplified because 9 is prime. So this is your probability. Tune into the next video to learn about dependent events.